like a little whoop. Go ahead. But when you do this in large volumes, it takes tremendous water pressure and tons and tons and tons of pumps. You got to move this water in, then you got to move this water up, and you got to push this water through that filter and move this other water away. You got to concentrate some water over here, and you got to dispose of some water over there. It's not a single body of water being moved for desal. You have to understand that there are many, many, many bodies of water getting pumped in very different directions. A lot of it under very extreme pressures. So a desal plant is extremely complex. Look at how much thing over here and thing over there and thing over here. This only generates a couple little tanks of water. This is not filling like Hoover Dam volumes of water. This is like the Gibraltar Reservoir bodies of water. Yeah?
In the next couple of decades, do you think we're going to be relying on a lot of desalinization plants?
Not this kind.
Because they seem really inefficient, so is there like room for
They're
anything?
utterly stupid. It's like the worst possible plant. Like coal burning power plants, you know, since you already have some, it makes sense to keep using them. But in the long run, it is the worst possible option. There is great hope right on the horizon. 6 or 7 years ago, National Geographic said we would already have some of these in commercial volumes. I think we're still a couple years away from large-scale nanotech desal, but we're very close. Those of you that are into sciencey science, you might want to write these down. They're called forward osmosis, carbon nanotubes, and biomimetics. All different ways to push the salt on one side but let the water go through the other way. So you start with salt water, you pressurize it, and these basically filter the salt at the molecular level. This is one of those cusp technologies where right around now we're just waiting for the smart guy to build a slightly better mousetrap and it becomes cost effective and then it's checkmate. Remember, this is still ignoring a couple of problems. A lot of people don't live near the ocean, and it's very difficult to push the water uphill from sea level. So this is only reasonable if we have free electricity or for people near the coastline. The other problem is, what are you going to do with all that salt? It's a lot of salt. To bring your house a couple 100 gallons of water, which is like you plus another person for one day, that's like a gallon of salt you got to deal with. One of my students is like, but we eat salt, but we eat like that much salt a day, not like that much salt a day. So you got to figure out what you're going to do with all that salt. Essentially, you can put it into the ocean, but if you do the math on the global scale, that could actually shift global salinity a teeny bit, maybe more than we want to. And secondarily, how are you going to deliver that to the ocean? If you just leave all that extra salt on the coastline, that becomes a super saline patch without life. So ecologically, the disposal of salt is kind of disruptive. Yeah?
Have they been considering initiating more of the solar thing where with all the mirrors that shine to the magma salt to use it up for that?
I mean, you couldn't use it up on that. Right. That's a use for a couple trucks full of salt. Yeah?
I mean, you just like export the salt to like other places who like need it like for other uses, such as like laying it on the ground.
The volumes you're talking about are... Everybody's like, couldn't you use the salt? And I'm like, no, it's a lot. It's like, but couldn't you use the salt? And it's like, no, but it's a lot.
No, but like, you know, for like road salt and stuff like that, but like... oh, okay.
What I just said.
We can give it to a third world country.
What if I put it on french fries? Okay.
They don't need salt. They're already thirsty enough.
No, they do need salt.
For what?
You need that much
Yeah,
salt.
but okay.
Okay.
Put it in Russian.
No. Yeah.
Moving on.
Make rings out of it.
So moving on. Number 17, I want to remind you of that thing I said in number 13 about how cities do that thing where we limit our own supply by shedding our free water and instead polluting our neighboring water. The rest you can get out of the book on number 17. I'd like to talk quickly about number 18. There are two interesting trends. One of them is, even though population has been going up, we maxed out our water usage in the 80s. The most wasteful water usage was before your lifetime. So you are born in a period of growing awareness of water conservation. United States maxed out on water per human in the early 1980s. Population has continued to grow, but overall water consumption has been mostly level since then. What's interesting, though, is who uses that water. I'd like you to notice those color codes: rural, public, irrigation, thermo, electric, and industrial. And now notice which of the bars is the largest. You know, electricity, where you have to heat up all that water to make the steam, and then you have to use all the cold water to condense it back down into liquid. Now, most of that water is technically returned into the bodies of water, but the primary user of water in the United States is thermoelectric. The primary consumer of water, water that's not put back in the system, is agriculture, the next biggest. Do you understand the difference between user and consumer of water? You can use it and return it, thermoelectric, or you can use it and then it's gone, like agriculture. Very little goes back into the system. So here are your two biggest targets for water conservation. And let me remind you, like I said earlier, that lowering the demand for electricity is the cheapest option and the least environmentally harmful. And here's another side benefit: it saves water for food. FYI, in number 18, you might want to add, the primary use of water by cities is outdoor irrigation, like lawns and parks and stuff like that. The primary use inside your house, anybody know what that is? The toilets, flushing away the pee-pee and the poo-poo. It's kind of funny, but you put more water into the toilet than you put into your body on any given day, and it's the same drinking water. Not what you personally add to the toilet with your nether regions, I mean when you flush, that was water. So your toilet uses more water per day than you do. My buddy Rob, you wash your hands in the sink, and that goes to fill the toilet, so you wash away your turds with the last time you washed your hands. It's kind of cool, to use that water twice. Okay. I'll warn you that number 19 gets 2 stars, and I'm not doing it because your book does fine. The College Board is obsessed with conservation. They want to ask you how to save limited resources. They'll ask you about how to save food. They'll ask you about how to save soil. They'll ask you about how to save fossil fuels. They'll ask you about how to save electricity. And they'll ask you about how to save water. Number 19 is how to save water. I'm not doing it because your book does fine. So how do we save groundwater? Number 20, ask Santa Barbara, because people from all over the world come here to see us do it. Santa Barbara is like a world leader on water systems. People from all over the world come to visit your city water people. Like if you work in the Santa Barbara Department of Water, whatever, like you can get a job anywhere you want. You should write that down really quickly because I'll show you a diagram soon. If you looked at your book, which a couple of you probably did, you might have noticed that the diagram of the water system is your local diagram. It says Santa Ynez and Chuma and stuff like that. I don't know about you, but I love our book and how much of it is local. I love that.
Is that because the person who wrote it, or is,
Both of the dudes are UCSB professors.
is that why? So it's kind of based here, or is it because you're just bad and because we're
They're
also
UCSB
really
professors.
good?
Yeah, they're UCSB professors.
Okay. So
I think she's asking me, would Santa Barbara still be featured
Yeah.
in the book if it was written by people?
Well, I think that there's other interesting examples. It's just they know about this stuff because they've been here a long time, yeah. And so they already have all the research at the university, and they know they're going to use it to teach their classes at the university. So, yeah.
Does everyone in the United States use this book?
No, but many people do. Check it out. We in this city do everything right. We get a ton of recharge. Do you guys know that we have more square footage of parks per capita than any other city in the United States?
what?
Why can't all of you care that much? Yeah, we have more square footage of parks.
Central Florida? What classifies a park?
You know, like green space and stuff.
So not like playgrounds and stuff, or that included?
I don't know. So look, we get a lot of recharge in Santa Barbara. We only use the wells when we really need to, and we only take out about as much as is returned regularly. So we have a very sustainable, we're pretty smart with the checking account. We only spend about as much money as we deposit. That's how we use our groundwater. We buy state water when it's cheap. We have a pretty fish-friendly reservoir. We have a few other reservoirs, actually. We have a bunch of reservoirs.
Why is it good if it's fishermen?
The Kachuma one is pretty fish-friendly because it spits out some water seasonally to give the steelhead something to swim in when they're coming uphill. It's also constructed to allow fish migration beyond the reservoir uphill.
It's not natural.
Reservoirs are not natural, they're built by man. Well, they're called rainbow trout there, but yeah. And something that we do that makes us super, super, super special is we reclaim wastewater. Santa Barbara has white pipes for tap water, black pipes for wastewater. That's all going to the wastewater treatment facility. We're going to visit that on Monday the 24th, by the way. Where they use like a big old screen to remove all of the large solids, like feminine hygiene and garbage and leftover t-shirts. And apparently they find a lot of jewelry and wallets. Yeah, like people doing the dishes will drop a ring.
Drop their wallet.
Yeah, and people will like fumble, like trying to drop trowel over the toilet. It's like, oh, dang it. And like, pulling your cash.
Whoops.
Yeah. I would get it out, but I guess some people don't. Or maybe they don't notice. After they screen out all those solids, they have these giant tanks of bacteria that finish digesting your poo for you. Remember that your turd is falling apart. By the time it reaches the wastewater facility, it's just dissolved in water. So all those macronutrients get digested. All the dirt that washes off you and vegetables and clothing settles out. The water is oxygenated, so the bacteria get to finish all the digestion.
So is that chemicals or is that bacteria that's already in it?
Bacteria that's already in it that they culture there. So wastewater treatment is just about keeping the dookie bacteria alive until you can give them more dookie. Then they sterilize the water, and then we have purple pipes in Santa Barbara to irrigate our schools and our gardens and our golf courses. You've probably seen the sign, it says, do not drink irrigating with reclaimed water. This is a double savings. Anybody know how it's two different water savings?
We don't have to use fresh water to water everything.
That's right. We save drinking water by using reclaimed. And what's the other savings?
Oh, the trip to get the water?
Where does that water go after you irrigate the park and stuff? That's right. It also recharges groundwater supply. You see, if we did not reuse our wastewater, first of all, we'd have to use up some freshwater supplies, and second of all, we wouldn't be adding to our groundwater.
Ask you one quick question. Which store do you here coming from?
I'm sorry, I kind of feel like right when I was trying to make a point, there was like 3 separate groups of students talking. I don't know how to make this an appealing offer. All you got to do is stand up and you can have an unlimited conversation outside with no penalties. The chairs can't be that comfortable, right? Like, please, I know that they're awkward, they're not comfortable. You can just go. But please don't interrupt, because some kids are trying to hear. The double savings are that you don't waste the water for the irrigation and that you get the recharge benefit. I mean, how infantile would it be if I had to do the whole discipline thing because you just didn't want to take me up on that generous offer to just leave the room? How much more appealing do I have? It's like, here's the nicest way I can do this. And you're like, no, I'd force you to do the dick thing. Just go talk outside, no problem. Don't talk when I'm talking. It's not polite to students that want to learn. I don't care if you disrespect me. You don't have to like me. Nobody likes me. But you should respect each other, please. Some kids actually do need class time. They're worried about their grades. If you're not, congratulations. I don't care. Question?
Why don't we use recycled water for it's such a waste?
Because we built our infrastructure around single-use water supply. We built all of our cities dependent on the provision of drinking water. And then we started thinking well, I can afford it. Why don't I put a law around the house? So it's well, use the drinking water. And then it's we got all this water going to waste. I'll use the drinking water. When Jose is president, we'll make a one-time mega investment and get 5 different grades of water. So you've got industrial water that just gets downgraded to go be used somewhere else, that gets downgraded to go be used somewhere else. Oh, there's 2 reasons though. Another reason is the water's all going downhill. Pumping water uphill is a big waste of energy. That's another reason. Yeah. Yes?
Why can't they use salt water in power plants?
Why can't they use what?
Salt water in power plants.
A few of them do, but only the coastal ones. Most of that water that you saw for electric was not coastal. Anybody else on number 20?
So 20 goes the reclaimed water.
Yeah, that's the reclaimed water thing. All right. So number 21 gets 2 stars. This is a big whoop talking about wetlands. And we've been here before. We've talked about wetlands in the past. You remember these things. If you did your homework, you already wrote them down. There are 6 reasons why we love wetlands. If somebody did the homework, you can save me a lot of trouble. If not, you might just remember from before in the class. 6 reasons. Number 1,
Natural sponge.
natural what?
Sponge.
Yeah, the sponge effect. And remember, the sponge effect prevents flooding downstream.
Provides a habitat for migratory birds.
Yeah, you can call it the nursery effect. It's nice for birds, that's cool. But it is also nice for the fishies and the bugs. As a nursery, it has benefits for many species, not just the birds.
Nursery, meaning like
Nursery, like for babies to get bigger.
Groundwater recharge.
Groundwater recharge, yeah, the longer you keep the water in one place, the more it goes into the ground. Yeah, that's one that we often forget. We've got all this extra carbon, that's a big old problem. You guys remember how you make coal? Partially decomposed plant material? This is what you find at the bottom of every wetland. So by having a wetland, you've got a place for carbon to leave the biosphere and get stored in an organic compound. Put away the carbon. Yeah. What else?
Filter that purified water.
Yeah, and you can call that bioremediation if you want.
Also, it's discharge zone, right?
I don't know what that means.
Said that it's the water to be recharged and discharged.
Oh, sometimes, yeah. So if it's below that surfaces, yeah.
I have a question.
Yeah.
Would the bottom of a wetland be considered an anaerobic environment?
Depends how deep it is. Also depends how still it is. And one that nobody has mentioned, wetlands on the coast are a buffer against storm surges. So there's lots of good news about wetlands. Imagine how much water is soaking into the ground or being filtered, how much habitat this provides, how much carbon is being stored, how this protects the people that are living behind it or downhill of it. But in the United States, we still had a better plan. Half of America's wetlands have been turned into farms or houses. And California has lost the most of any state by square mile. We've lost 90% of California's, and we had the most to begin with. That's why our state's biggest chunk of the economy is agriculture. Because we have a lot of land that has really high groundwater and has really high quality soil, lots of nutrients in it. Imagine, north of that farm or in front of that farm, if you just flatten that stuff out, you've built one heck of farmland. So by the 1960s, we'd used up almost all of California's wetlands for this purpose. Starting in 1969, we had to start making man-made wetlands to replace natural wetlands whenever we built a farm. Anybody know what you call that?
Fire mitigation.
Oh, no.
Mitigation?
But the,
Mitigation.
that is a type of mitigation. You do bioremediation. And what do you call a man-made wetland?
Expensive.
You don't talk anymore. Oh, somebody said it. No? Bioswale. That's a term you got to know. Man-made wetlands.
Jose, when are you going to talk more about the field tree?
I don't know, whenever I get it approved. B-I-O-S-W-A-L-E. Okay, so unfortunately I'm going to stop here. The period ends in like 2 minutes, but I don't want to start on the next PowerPoint. Are there any questions I can answer for you while I'm waiting for the bell?